Right, now we're going to talk about combinations. And with combinations, order doesn't matter. So we know that we've got these 6 flavours of ice cream: chocolate, vanilla, strawberry, orange, lemon and raspberry. And instead of talking about permutations where order matters, we're going to talk about combinations where order doesn't matter. And we can often use a C to denote that. And again, we use the same symbol as before. We've got 6 different flavours, so that would be the number before. And we're allowed to choose 3 different scoops of ice cream. So we would denote it in the same way, that the number of possibilities is 6, and the number of flavours that we can use is 3. And we're looking for combinations. So if we were going to say that I'm able, the first time around, to choose any of these 6, so the number of combinations would be just like the last one. First time I've got 6 ice creams to choose between. Second time around I've actually chosen one now. Let's say that I take lemon. I can't choose lemon again, so I have 5 more possibilities. I could put the lemon together with 5 other different flavours. Third time around, let's say I've chosen raspberry now. I only have 4 different possibilities left, so I have 4 more possibilities. So let's have a look at that. Let's look at lemon together with raspberry and, let's say, chocolate. Now, it doesn't matter with combinations because order doesn't matter when it comes to a combination. If this is LRC or RLC or CLR, they are exactly the same thing because in combinations order doesn't matter. So what do? We actually have to divide by this number here as a factorial. Factorial, we know that means, so on the top we have 6 times 5 times 4 divided by 3 times 2 times 1. Because we're going to have lots of situations where it doesn't matter whether it's lemon, raspberry and chocolate, or raspberry, lemon and chocolate, or chocolate, lemon and raspberry. They're the same time. So it's not going to be as many when order did matter, because these 3 things are all the same flavour, so we will be dividing by 3. And then if we look at, the other orders, we would find that there are 2 more that are the same, so we would divide by 2. So we would get, here we would divide 2's into 4, which would go 2 times, or 3, in fact, let's leave the 4 there. We've got 3 times 2 here, which is 6. So 6 divided by 6. And so here we have 20 combinations. So when order doesn't matter, it reduces the number of chances of the event happening a lot, because we divide by the number of possibilities, the number of flavours we wanted, as a factorial, always. So permutations is just 6 times 5 times 4, whereas number of combinations is 6 times 5 times 4 divided by the number of scoops we had as a factorial, 3 times 2 times 1, which would give us 20 possible combinations in this particular case.